this right here is going to dictate a lot of your understanding with lines. We said that the slope of a line is consistent, right? I'm going to write that. What that means is between any 2 points, it's not going to change. It's the same between any 2 points. So once we find that, if we can find a way to quantify, if we can find a way to put that into numbers, we can use the same system, the same number we come up with, to graph from one point of the line to any other point. Because remember, we did say that looking at some line, I'll draw this one here, that looking at some line, the points, the ordered pairs that you could have found in that table, there's infinitely many. They're so close together they blur to make that line, right? So the idea is that you can use this consistent slant, this consistent slope, to go from any one point to the next point. Basically, it's an idea of a definition. Math people come up with a system and they say, you know what, it's a matter of how we define slope. Everyone would just have to be consistent with it. So this is a definition. Let me explain the situation. You're at this first point and you want to get to the second. What two things are changing? If you're trying to describe somebody's direction on how to get from the first point to the second. Both things are changing, right? The x and the y are both different. I mean, there's some change. In this case, it went to the left some amount, right? The x changed by some amount, and it also went up by some amount, right? The idea with slope is that change to the side and up is going to be consistent. So what we as math people do, what we as people who are dealing with lines do, is we say, let's make a comparison. Let's use a ratio, a fraction, to describe the relationship between the side-to-side movement and the up-and-down movement. And guys, I'll tell you, it's trivial. When they made this definition, they just picked their favorite one to put on top and on bottom. And they had to make other rules according to it. They're probably pretty careful because it works mathematically better to do it this way. But the idea is that any slope is defined if you use the words the rise over the run. The change up and down in comparison to the change side to side. That's the slope of a line. That's how we talk about it. It's just a fraction where we compare those two changes. Now rise, up and down stuff. Are we talking about the y's or the x's on top? Okay. So if I wanted to put it in more words, I could say the change of the y's, right? In comparison to, on the bottom we're saying it's the change of the what? X's. Now the reason I write this out in so many steps, guys, is because when I was a student, I had trouble memorizing just some random formula, but I could remember rise over run. So for me, the way I would get back to the formula that you guys are going to need to be comfortable using is I would say rise over run. Then I would say, oh, that means change of y's over change of x's. So that's the way my brain worked to help connect me back to not writing the formula upside down. If you're getting a change of something, how can you get the distance? How can you get that change? I mean, let's say you're a math person. You're trying to find a way to describe this. I start at point 1 and I walk 3 feet past it to point 4. What was my distance? I'm standing on some line. We'll call it a number line. I start at point 1, and I'm going to say 1, 2, 3, 4. I'll walk to point 4. So that's my change from 1 to 4. What is the change? How'd you get that? Oh. If you want change, if you want distance, you subtract, right? Now, sometimes with distance, we used to use absolute value stuff, right? If you take stats, they'll put some absolute values in there for you. But when it comes to slope, we say, you know what? That positive or negative tells me some valuable information. It's going to tell me the direction they're going. I mean, see, if I have a positive 3, it means I went to the right 3 places, doesn't it? If I had a negative 3, let's let that mean I went the other way. On the line, that would mean I went down. So we let the positive and negative stay, we just subtract. So what we would say here is slope is equal to y2 minus y1 over x2 minus x1. That was just our thought bubble on why the change would mean subtraction over on the right. Notice something. On the top, which y comes first, y2 or y1? On the bottom, which x comes first, x2 or x1? Wait a second, that's just two letters. It's two different y's with a minus and two different x's with a minus. Why would they be using those subscripts? Why would they be using a 1 and 2? Are they trying to symbolize something to me even in the formula? Yeah, they're saying, you know what? Whichever y you use, let's say it's y from point number 2, you better be consistent. We don't care which one you call number 2. Pick your favorite. But on the bottom, notice, you have to be consistent. You have to also use that same x that matched with the y on top. In other words, with this line up here that I drew for you, let's make up some points. I'm going to say, you know, this is 0, 2, and this can be, I don't know, -2, 0. So I'll say those were the 2 points. Let me write them down here. So we have -2, 0 on our picture, and we have 0, 2. So we used intercepts here. That was nice. That keeps our math pretty easy, actually. Not always the case. You're not always required to have special points that have zeros in them. You can have any kind of x and y combination, as long as it's points on that line. But the idea is that I can use these 2 points. The idea is actually I can use any 2 points on that line to find the slope, to describe the incline on my picture. Let's do it. Which one do you want to call point 1? The top one?
No, I'm asking a question.
Go ahead.
What's this y2 and y1?
I'm showing you. It's a way of notating. You know how on a point you have x, comma, y?
Yeah.
It's a way of saying which one's 1 or 2. You got to have some way of differentiating. So, for example, -2, 0. Do you want to call it point 1 or point 2? How about point 1, since we started there? It doesn't matter. I'm just going to say point 1. This would be point 2. The idea is those subscripts only mean be consistent. If you want to use this one as your second one, slope is equal to, which one's the y in the second point? The 2? So 2, right? Take away, what's the y from the first one? 0. So you see how we did 2 minus 0? The point here now, I shouldn't use the point, it's the word point, but is that on the bottom I have to be consistent. Since I used 2, what must I use now for the first x? 0. I have to use the same exact ordered pair first on top and bottom. 0 minus a -2. Oh, be very careful, guys. I didn't mean to give you such a tricky one first thing. But yeah, the formula has minus in it, doesn't it? So minus a -2 is what you would write. Yeah.
So the y2 or the y2 and y1 doesn't have anything to do with, like on your little line you drew, it doesn't have anything to do with the first point goes, like, because you got the change of 3. It doesn't have anything to do with, like, you got to switch to 4.
Well, it totally does. I mean, really, this right here only had one dimension in mind. So on this one, we might have said, okay, well, we're going to say that 1's where the person started when they were walking. So we'll call that point 1. And we'll say 4 was where they stopped. So it would have been 4 minus 1. Now, see what happens with these points, though, since they're not just on one line like that. If you had negatives and you had labeled it backwards, like you'd done the 4 before the 1, you know, you missed the order up, you get a negative divided by a negative. They cancel out. That's why the only important thing is not which point you classify as being the first point that's important. What's important is that you're just consistent with which one's your first one. Very good question. It's true. It would have made a big difference here in the thought bubble. because it would change the positive negative of that 3. But actually, since we have a division over here in the real equation, it'd be a 3 over something because you would have x movement and y movement. It would take care of the negative positive problem. The only thing that would cause it to go away would be if you didn't use the same point first and the same point second. 2 minus 0, what do I get? 2? 0 plus 2. Oh, what's the slope of this thing? 1. Slope equals 1. Wait a second. Didn't we just say that slope had to be a fraction? I mean, didn't we just say it was a comparison of the change in y's to the comparison of change in x's? Could someone please tell me what is 1 if I want to write it as a fraction? Oh. So a positive 1, would that mean up or down? 1 up. And a positive 1 on the bottom, would that mean 1 to the right or 1 to the left? How do I know that the top's up or down and the bottom's right or left? It's rise over line. It's up and down over side to side, right? So this is my road map, guys, from any point to the next one. I'm going to walk up 1 and to the right 1. That's what we just now discovered. So, for example, let's say I only had one of these points. I don't know. Let's say I had 0, negative 2. 0, negative 2. To get from this point, any point on that line, now that I know the slope, describe to me how to get to the next point on this line. So up 1, then to the right 1. Okay. Oh, it's the same point, isn't it? And there's another one. Okay, so when I'm here, to get to that next point, I go up 1 to the right 1. Up 1 to the right 1. Oh, look, I could keep drawing forever. I could keep my stair stepping going on forever. Cool. The most important thing you've seen so far today, let me see if I can highlight it or something. First, I should cap this marker, though. The most important things you've seen so far. I want you to know that slope really is rise over run. Make sure you got that, okay? That's going to be what, that looks horrible. That's going to be what helps you memorize the formula. Know the formula, obviously. If you had to put it, if you had to say y is on top, x is on bottom, make sure you can go from the rise over run to x over x. Y over x, excuse me. And then this roadmap, this idea of how to interpret it, that's kind of important. Because that tells you how to go from one point to the next. Looks way better on you guys as presenter than this thing. I wish we could get this thing feeding.